Welcome to Univar Solutions Innovation Day. My name is Brandon Beyer. I'm a global manager for application development aligned to household and institutional cleaning. I'm going to take about 20 to 30 minutes right now to talk about the future of cleaning, the enzymatic solution, basically how today's enzymatic solutions and microbes can help with tomorrow's cleaning challenges. So what is the future of cleaning? Is it advanced robotics, machine learning, AI analytics, maybe some new packaging or dispensing systems, chemical innovation? I don't have a crystal ball, but we can talk about a few of the current innovation trends in the future of cleaning. Chemical innovation is less of a trend and more of a constant. New and novel technologies arrive every day, and I would say nowadays, how you make the molecules is as important, if not more important, than the chemistries themselves. Even the once touted art of formulation has been reduced to combinatorics. We live in a world of smart everything. Smart cars, smartphones, and smart technology is part of the future of cleaning because utility monitoring informs water consumption and energy consumption, particularly for larger buildings. It drives data-driven product dosing, and hygiene analytics and reporting can actually tell you when a surface, room, whatnot are actually clean or need a cleaning. Biome control is not something that's as familiar to everyone, but it is enabled via microbial cleaners. We now have the ability to have access to control the biome or bacteria in our home to give access to continuous cleaning. Nothing says future like robots. Robots, you may laugh, but the reality is these could be as simple as something like the Roomba, that is a robotic cleaning instrument, or as advanced as the UV kill bots we saw sweeping hospital rooms and continue to see that, removing microbes and whatnot during the COVID-19 pandemic. If we remove robots from these four innovation trends, chemical innovation, smart technology, and biome control are all enabled and enhanced via enzymatic and microbial cleaning products. Talking about the future of cleaning, let's get into the modern consumer. So the information age has created an increasingly educated consumer. What do they want? Well, they want a cleaner clean. They want products to clean very well. They would like the products to be safe. They want green chemistry, and I have this in quotes because green is a nebulous concept, and we'll talk about that a bit more in a slide. They'd like eco-friendly packaging. Multifunctional cleaners, or one cleaner to rule them all. Ideally, labeling transparency. Environmentally responsible manufacturing. They would like the product to be easy to use and, as always, cost effective. If you start on the side of enzyme or microbial cleaners, you're in luck because 7 of these 9 parameters are already enabled via these solutions. You could actually say 8 of 9 because labeling transparency is very easy. You're not hiding anything proprietary. You say you have a protease, an amylase, a microbe present, and you can say that proudly. I want to go a little further into that green chemistry piece. Future of cleaning, and we see this especially this year, and it grows every day, is a need for sustainable solutions and a look to the future of our environment. This leads to green confusion. What you see above here, these 5, Green Seal, Safer Choice, REACH, EcoCert, whatnot, are a small sample of what are eco-labels. They all have different criteria, different needs, and directionally, they're all going in a positive, sustainable future. But it leads to a lot of confusion. When a customer comes or consumer and says, I want to go green, I'd like to be green, you always have to answer that request or question with a question. What does green mean to you? It can help to make a tool like this. It's a calibration tool that I created. So total disclaimer, this is nothing beyond Univar Solutions. This is something that I put together to kind of help orient where the formulator is at right now. So from left to right, we're looking from less green to more green. And it is not bad to good, because make no mistake, on the far left here, nonylphenol ethoxylates and sodium tripolyphosphate are fantastic cleaners. They just come with a little bit of green bag or a little bit of environmental baggage. So you have a customer come and they like to be more green. Now, if they're starting a new product portfolio, you start on the far right side with microbes or enzymes, and you're already in the fully green segment of the formulation spectrum. This could be iterative. You can move a little bit from left to right or all the way in one fell swoop. The main point and takeaway is for the future of cleaning and a sustainable future, enzymes and microbes are probably where you want to be. So let's talk about those enzymes a little bit. In particular, 3 core cleaning enzymes: protease, amylase, and lipase. Proteases are among the first enzymes used in cleaning applications and have been around 50, 60 plus years. They are now a basic ingredient in both laundry and dish products, and effectively they cleave proteins into smaller chains of amino acids. Some common protein stains you can see listed here: meat, grass, milk, blood, sweat. Amylases work on sugars, or more specifically, starch. Starch soils can act as a glue for dirt particles from the air and wash water to make stains worse and lead to a dingy look in fabrics. So amylases effectively cleave these starch molecules into more manageable sugars. Potatoes, pasta dishes, gravy, condiments, whatnot are very common sources of these starch soils. And the last of the core cleaning enzymes are lipases. So greasy stains are among the most challenging to remove, especially from synthetic fabrics, like a polycotton blend. So the lipases effectively cut lipids into smaller pieces, and they're fatty, so they can get readily incorporated into surfactant micelles and then carried away in the wash water. Common greasy stains: cooking oils, fast food, butter, and even a lot of cosmetics. So this represents 3 core cleaning enzymes: protease, amylase, lipase. There's a second tier, and not second tier in the sense that they're just less common. And that's the mannanases, the lichenonases, and the pectate liases. Mannanases might not be as familiar to people, but they effectively cleave galactomannans into simpler materials. So what are galactomannans used in? They're used in the food and industrial applications as stabilizers and thickeners. Much like starch stains, they can serve to provide a surface for additional soils, which makes them tricky because they're invisible. So you'll do a wash, you think your shirt, your towel, your napkin, whatever is clean, the stain remains. Every time it gets a little more dingy, a little more dirty. So the common mannan stains are guar gum, locust bean gum, some personal care products, again, things that require stabilizers and thickeners. Lichenonases are a class of enzymes I think are set for a big boom in the coming years. Why? So these cleave, and this is a 10-cent word, hemicellulosic polysaccharides, and they cut them into more manageable sugars. What are those? What does that mean? Well, current dietary trends and high fiber foods, as well as plant-based milk alternatives and plant-based foods, think the Impossible Burger, Impossible Sausage, and whatnot, are loaded with these hemicellulosic polysaccharides, creating a whole new class and challenge of stains. Common fiber stains are oats, barley, quinoa. These are things we see. But oat milk, so if you have a coffee and milk stain versus a coffee and oat milk stain, or almond milk, very different things. I think this is where the lichenonases can really shine. And the last is the pectate liases. Pectin stains arrive from both natural and processed foods, mainly think fruit, jams, and juices. So once again, these are cleaving pectin molecules into more soluble short-chain sugars. So smoothies, tomatoes, bananas. I think it's very familiar to anyone who has typically a toddler spilling, jelly all over their shirt. But the combination of these 3, I think, represent not the first pass of the enzymes, which are the protease, amylase, and lipase, but a very important class for supplemental cleaning. Then there's the cleaning and care cellulases. These are a little bit different, so I'll highlight them both. Cleaning cellulases basically prevent redeposition of non-bleachable soils from dirt, clay, mud particles that can lead to fabric graying and color dullness over time. Basically, small particulates get trapped in splintered textile fibers, thinking like little frayed cotton particles, and it creates a general reduction in the brightness of your clothing. Cleaning cellulases function by cleaving those, basically giving a very fine haircut to fabrics to then release those dirt particles. It's a complementary cleaning mechanism to common anti-redeposition agents like polyacrylates and polymaleics. Care cellulases work in a very similar fashion. Basically, they do that like a haircut of the fiber, but it's a much bigger cut, and these kind of help effectively remove fuzz and pill buildup on cotton fabric. They provide both a maintenance and repair effect on the look of cotton. It's restorative. So similar to cleaning cellulases, they modify the surface to restore color and or whiteness. And it's an alternative technology to traditional optical brighteners to really give a pop to your aging or aged fabrics and clothing. New kid on the block is the phosphodiesterase. So before I get into talking about what the phosphodiesterase does, let's talk about the soil it's targeting. And it's a disgusting one. It's body grime. So body grime, like the mannins and like the starches, is invisible to the naked eye, but it builds up and traps dirt, bacteria, and odors. So you might wash a shirt with a really effective laundry detergent with a lot of fragrance, and the fragrance will mask the odor, but it doesn't remove it. Even sanitizers and bleach can serve to kill like a lot of the odor-producing bacteria in a fabric, but the remaining soil base, the body grime, will remain, leading to recurrence of the washed clothes not feeling as fresh or as clean. So what is body grime? It's a blend of DNA, RNA, sugars, proteins, just all the schmutz that falls off of us on a daily basis and gathers up in our fabrics. Enter the phosphodiesterases. What do? The new class of enzyme that's currently entering the market, they're also referred to as nucleases. Their target substrate is extracellular DNA, also called body grime. They cleave the phosphodiester bond found in eDNA, and as I mentioned, the body grime acts as a glue for dirt and malodors. One interesting thing with the phosphodiesterase, and this is anecdotal now, but data is coming to show they seem to have a really strong synergy with other materials, other enzymes, the amylases and the proteases, because as you're breaking down, which you can see here, eDNA, proteins, whatnot, you're creating other soils that can then be cleaved by additional enzymes in solution, leading to good synergistic benefit. And this is actually kind of true for most multi-enzyme solutions. The sum of multi-enzyme systems is often greater than its parts. So this is a qualitative representation of this, but we can provide data to just talk about this. But as you can see along the bottom here, we've got the singular enzymes, protease, amylase, pectate lyase, the care cellulases. If you add them all up into a blend, and there are blends that do this, you would think the sum of the individuals' enzymes is going to be a pretty good performance, and it will. But the reality is, the synergistic reality, as it were, is they're greater than the parts. These blends are fantastic. They're pre-stabilized, they're easy to work with, and a really powerful tool in a formulator's toolbox. So, formulator's toolbox. You want to go forth and formulate with the enzymes. There's a few things to know about formulating, in particular, liquid enzymatic products. The first are polyols. Conventional approach when formulating a liquid enzymatic product is to incorporate 2 to 5% of a polyol, mainly propylene glycol and or glycerol. This is especially important when using boric acid protease stabilization, but I will say newer enzymes and newer blends are much more robust and may not require the addition of these polyols, or the manufacturer, something like a best-in-class manufacturer like Novozymes, will have this included in the blend itself, saving you the trouble. The same is true for calcium. Traditionally, you need to use a small percentage of calcium chloride for optimal protease and or amylase stability. Basically, remember these enzymes are giant proteins and they roll up, and things like calcium and magnesium help keep that folded structure in place so it can do its work. But once again, The newer enzyme variants don't require these, either by virtue of the enzyme themselves or clever formulating of the manufacturer in including these in the blends. Then there's pH. Typically, you cannot formulate outside of a range of 6.5 to 8.5. This is because enzymes are proteins and they want to be near biological pH. They come from living organisms and they function best in that space. A little more complicated, but something always to keep in mind is order of addition. And generally, you want to add your calcium chloride and sodium formate, which is another stabilizer, during the heating step if you have one. The addition of the enzymes should happen at the end of the batch. Ideally, especially if there's an exotherm and the batch heats up, you don't want to denature your enzyme and have it have no function because you added it too quick. Wait till it cools to at least room temperature, or if you have a cooling capacity, even a bit cooler. If you're making a multi-enzyme system, add each enzyme individually and don't pre-bill them prior to adding them to the batch. Alternatively, as I've said many, many times, using the pre-stabilizers and blended enzymes from manufacturer like Novozymes would be preferable. There is a time in the future where maybe we can use exclusively enzymes and or microbes or both to be all-in-one green cleaning solution. But currently, the conventional approach, we still need surfactants, polymers, chelants. And in relation to surfactants, our two big workhorses are anionics and non-ionics. Enzymes in general don't play well with exclusive anionic blends. So general rule of thumb, you want at least a 1-to-1 anionic to non-ionic ratio, preferably 1-to-2 or 1-to-3, favoring the non-ionic. LAS is a very common surfactant, anionic surfactant, and it can be a real challenge to enzymatic stability. However, if you can combine that with sodium lauryl ether sulfate, it's a bit more mild. It can kind of help preserve the enzyme in the face of other anionics. And once again, new enzymes arriving every day. So every week, every month, every year, we have a new class of enzymes and the ability, a more tolerant enzyme to even the anionics. A few other considerations: strong chelators should be used with caution. Remember, there's calcium and magnesium helping these enzymes function. And chelators function to pull those things out of solution or hold them in water. So use them, but use them judiciously. Avoid bleach and formaldehyde-releasing preservatives. They will denature the enzyme and remove function. But the isothioethanones, CMIT, MIT, BIT, as well as 2-phenoxyethanol are all fine preservatives to use. Use caution when blending with any type of oxidizing or reducing agent, because again, it can change the chemical structure of the protein. And lastly, most minor ingredients, fragrance dyes and whatnot, are not a concern. Now, I started talking about enzymes and microbes, and we've spent a lot of time here, probably 13 slides, basically talking about enzymes exclusively. So let's talk about microbes. We'll first start by talking about how are enzymes and microbes different. So enzyme, and the little picture I have here is the X-ray crystal structure of an actual protease. It's not a cleaning protease. My apologies. It's a stomach protease, but you get a sense of what they are. So these are produced by all living organisms. They're not, in fact, alive. They're very complex proteins. And an enzyme does a single, highly specific reaction repeatedly. It initiates bond cleavage thousands of times per second. Whether it's a protein bond, the protease, like a fat bond, a fatty acid bond, like a lipase, they do one thing really, really well. Microbes are living organisms. They take some time to awaken and show activity, so they multiply and clean based on nutrient availability. Nutrient availability is basically water and then the soil, stain, whatever. So their food is our stain. They typically contain, greater than 2 million proteins. So effectively, they're biologically nanotech or little enzyme factories. Important thing to take away when you're looking at chemistry, enzymes, and microbes is something we can call the probiotic cleaning model. Chemistry typically works immediately. So you add it to a surface, a wash water, whatnot, and the time frame in which it works is between like second times zero, a few seconds to a few minutes. Enzymes are pretty similar. They might take a few moments to get rolling, but they have very quick degradation of specific targeted soils. They can last from seconds to minutes, maybe an hour. Microorganisms offer the ability for continuous degradation of these organic soils, protein, starch, fat, volatile fatty acids, etc. But they take some time. It's typically on the order of minutes. It can be minutes, but where you really see these excel is that 1 hour to multiple days, weeks, or even months. Something just to be mindful of. There's always a question of, I don't see this working. Give it a day, give it a week, give it a month. And what you're seeing oftentimes is what we call competitive selection. The selection of the preferred microbes to unpreferred microbes or soils over time. Porous surfaces like grout, concrete, whatnot, you really see a benefit, as well as some of the more challenging surfaces, say like a carpet, that hold malodors from oftentimes pet stains, pet urine, whatnot. Microbes really excel in removing those soils as well as the odors. But just like enzymes, formulating with microbes comes with a few caveats. They're a bit more tolerant than enzymes, but there's some things to consider. So in surfactant considerations, your core cleaning surfactants, anionics, non-ionics, amphoterics, are all fine with microbes. A few things to note: anionic surfactants often have a little bit of preservative within them. It's part of their manufacturing process. A preservative and a microbe don't always blend well together, so this could have an impact on the microbe's germination over time. So just something to be mindful of when you're buying an anionic and blending it with your microbe. Know what you're putting in there. They're generally compatible. The alkyl benzene sulfonates, alkyl sulfonates, whatnot, tend to have some inhibitory effect. So I always recommend SLES. It's mild, it's available, you can buy it as vegetable-derived material. It's a really good go-to anionic surfactant for both enzymatic solutions as well as microbial. Non-ionic surfactants, generally compatible and recommended. In particular, if you're leaning towards the green side of the spectrum, the alkyl polyglucosides are a go-to. Amphoterics, so these are generally compatible. They're very pH dependent, but in regards to the amphoterics, you might want to avoid the cocamidal propylbutane, as it has the presence of a quad ammonium cation, which leads to the last bullet I have here, which is cationic surfactants, which are often used as antimicrobials in general, can impact spore viability and cause spore clumping. So you avoid the cationics, you avoid amphoterics that are heavily cationic, and you're in a good space for formulating with surfactants and microbes. A few other considerations: pH range. Again, microbes are biological, so 6 to 9, mainly in that 6.5 to 8.5 is where you want to be, biological pH. Chelate considerations. They're very compatible with chelates. I've listed sodium citrate, the MGDA, GLDA, primarily because they are green options. Same with the amino disuccinic acid. The polyacrylates, polymers, whatnot, EDTA are also fine. Preservative considerations are tricky because, as I said, preservatives are designed to inhibit biological growth or kill it entirely. So you don't recommend peroxide, bleach, peracid, glutaraldehyde, any formaldehyde releasing agents. The CMIT, BIT also can be used, but you got to be really careful because, again, it could kill the bug. But for the most part, you want to work with 2-phenoxyethanol. It's very tolerant. Just to note, it's not registered preservative in all countries, but it is available in the US. You could use the sorbates as well. Think the sodium benzoates. But again, their greatest efficacy is below pH of 6, and there are ways to stretch that, but you start to really hamstring yourself in terms of formulation, where you're stuck between pH 5.9 and 6.5, and maybe not the best approach. Lastly, there are enzyme boost considerations. I don't think this is an industry term, it's just a term I use, and it's basically adding enzymes in addition to the microbes. So you can really take advantage of that whole probiotic cleaning spectrum where you have immediate action from enzymes and then long-term action from the microbes. So enzymes can be included with the spore package, but you really want to be able to monitor and make sure that your enzymes are doing what you say they're doing. And if it's something like a protease, it doesn't in fact break down the spore. But these products exist. They have existed for a very long time, and they're very effective. Lastly is fragrance considerations. Generally compatible, but some of the natural fragrances, think essential oils, can have an inhibitory effect or kill effect on the spores. So if you want to stay completely green and lean towards, say, a natural terpenoid fragrance, test for viability to make sure it works. So that's a little bit of an overview for Univar Innovation Day on the use of enzymes and microbes, how to formulate with them, why we should care about them, and how they represent a future of cleaning. I hope this was very informative, and thank you for your time.
Welcome to the Univar Solutions Global Solutions Center in Essen, Germany. My name is Katarzyna Rubek-Szewiro, and I'm an application specialist dedicated to home care and industrial cleaning.
I am Irina Ferenc-Gabriono, Junior Application Specialist for HIC and BBC. Today, we are going to show you how a new formulation of manual dish soap is developed in the Solution Center. So, Kasia, could you please tell us more about which ingredients are generally formulated in a liquid dish soap?
Well, the overall composition requires water, surfactant, thickener, preservative, as well as an additive to improve product sensory feeling, and, of course, fragrance. Our formulation differs from the others because it also contains hero ingredients from our suppliers.
One of them is Intensum for 220L, supplied by Novozymes. It is a blend of protease and amylase, which makes it easier to clean the toughest soil on dishwashers. Protease hydrolyzes protein, while amylase breaks down the starch. Therefore, the solubility of soil is enhanced and can be rinsed off easily.
While we are doing the dishes, our hands will directly interact with the product for some time. For a long-term usage, harsh formulation can cause skin dryness. Thus, a skin-friendly formulation is sought after. In this case, we have incorporated aloe vera from Polestar to moisturize and protect the skin barrier.
On top of that, our formula benefits from Univar's Teflon APG C810, the regulate, biodegradable, and renewable non-ionic surfactant. It has superior performance as well as foaming properties, which is desirable in a liquid dish soap. Now, let's get into the exciting part, formulating in the lab.
To start the formulation process, ML 270D, Teflon APG C810, Betadet HR, Accusol 505N, Teflon BIT20 are weighed out. Then water is added. This first mixture is going to be homogenized with dissolver to ensure incorporation of all the ingredients. Subsequently, Biochemica BioVera 200X aloe and PDV salt are added, and the pH is adjusted to 6.3 with citric acid. Lastly, Intensa Core 220 is being introduced into the mixture.
Before we start the performance test, we need to make sure that relevant states are available. There are generally two types of states used for performance tests: technical and natural states. While technical states are standardized and provide reproducible results, natural states are usually handmade from food, drink, or other substrates, and more customer realistic. Besides that, there are four soil classes: bleachable, persistent or alkaline sensitive, starch containing, therefore amylase sensitive, and protein containing, so protease sensitive.
To test the cleaning performance of our liquid dish soap, we prepared handmade stains, which are black tea soil in the coffee mugs and crème brûlée on dessert plates. All the mugs and plates were thoroughly pre-washed in a laboratory dishwasher at 93 Celsius degree with a high alkaline commercial detergent. To prepare the black tea stains for 15 coffee mugs, the mugs were heated in the oven to 85 Celsius degrees. Subsequently, 2 liters of water were boiled just to add 30 grams of black tea that was brewed for 5 minutes. 100 milliliters of tea were poured into the mugs. The pouring temperature has been maintained at 93 Celsius degrees. Every 5 minutes, 20 milliliters of tea were removed with a pipette. This process was repeated 5 times until all the cups were empty. The same procedure was repeated once more with freshly brewed tea.
To prepare the creme brulee stain, the ready-made mixture was heated to 60 degrees Celsius while stirring. Then it has been let to cool below 30 degrees Celsius while stirring occasionally. 3.5 grams of creme brulee were applied on the dessert plates and brushed evenly. After drying the creme brulee on the plates for 2 hours at room temperature, stains were baked in the oven for 2 hours at 140 degrees Celsius.
There were 5 different formulations with 2 variations tested. 2 formulations with enzymes and 3 formulations without, with different ingredients. 1.5 ml of dish soap was applied on a sponge. Then, each mug and plate were rubbed 3 times in circular motion. The mugs were rinsed with running tap water 3 times, while the plates were rubbed once again in similar manner as before with the sponge's scouring pad, without adding any soap on the sponge.
During the test, cleaning, sensory, and form performance were assessed. As a result, the formulations without enzymes were able to clean the mugs and plates optimally after leaving the rest of the soap for a few minutes and rinse with water or rub with scouring pad. The normal liquid dish soap cleaned the stains in the mug directly but could not remove significant amount of creme brulee stains.
To summarize, the formulation development in the Solution Center involved ingredient research, formulation in the laboratory, stain making, and performance test. The gentle liquid dish soap showed an excellent performance to clean the handmade stains, mainly thanks to the enzymes.
Thank you for watching and listening. If you have any questions and inquiries, please do not hesitate to contact us.
Thank you.
We share the world with bacteria, and as it turns out, some of those bacteria are beneficial to our microbiome, a combination of living microorganisms inside our homes and even in the human body. By killing 99.9% of bacteria, we are inhibiting microbes from coexisting with us harmoniously in our microbiome and potentially increasing the risk of health problems. Rather than remove these beneficial bacteria through over-sanitization, we can join forces with them to keep our environments healthy, clean and safe, the way nature intended. Here's Jamie. Jamie embraces microbes for a more balanced, healthier clean. Not only are these microbial cleaners safe for Jamie's family, they also maintain powerful performance that lives on. The microbes in Jamie's cleaner work around the clock, targeting tough residues and stains left behind, and tackling hidden dirt and grime. The microbes extend various cleaning applications for days across a variety of surfaces. They effectively control the unwanted bacteria that produce stains and bad odors long after they've been applied. Compared to others on the shelf, microbial cleaners offer the tough performance consumers desire while meeting sustainable and clean label standards. At Univar Solutions, we can help you understand how to bring microbial formulations into your cleaning products for the modern-day consumer. Now is the time to let nature in with sustainable products that support a more balanced and healthier microbiome. Explore what happens behind the science and discover how microbes provide powerful solutions for your home care and industrial cleaning applications.